Here we have a problem that we're going to use to discuss how to simplify after you use the quadratic formula. We have the equation x squared plus 6x plus 3 equals 0. And our instructions say to use the quadratic formula to find any real solutions. And you need to provide an exact answer using radicals as needed, and you have to simplify completely. So the first thing you do, you use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And you can only use this formula whenever you have a quadratic equation that is in the form of ax squared plus bx plus c equals 0. And luckily for us, we already have our equation that's in that format. And so we just have to identify what the a, b, and c are. And so we look at our x squared term and we say there's nothing out front there that's multiplying. That means there's an imaginary 1 right there. If it were a 0, you would not actually have an x squared term. It has to be a 1 because that's a multiplier on the x squared. So that means that our a is 1. Our b is whatever is multiplying our x term. And it turns out that we have a 6 multiplying our x, and so that's what made our b equal to 6. And then our c was the constant term at the end, which is a 3. So then you take these numbers and you plug them into the quadratic formula, which gave us negative 6 plus or minus the square root of 6 squared minus 4 times a. Well, we said a was 1. Times c, we said c is 3, all over 2 times a was 1 again. Then simplifying in our first step, we take our 6 squared and we actually square that out. So we leave our negative 6 plus or minus. Underneath the radical we get 36, and then minus 4 times 1 times 3. 4 times 1 is 4, times 3 you get the 12. And then on the bottom 2 times 1 is just 2. Then simplifying in the next step, we just do the 36 minus 12 to get 24. Everything else stays the same. And at this point is where students have been having difficulty simplifying. The first thing to do is to simplify your radical. Now, if this were something like a 25 or a 36 where you could actually take the square root, that would be nice, and then we could just take the square root and then do our addition. And in a separate step we would do a subtraction, and then we would divide by 2 and we would be good to go. But in this case we have a 24, which you cannot just take the square root of. So then we have to simplify our square root. When we talk about simplifying a radical, what we mean is we want to break it apart into its factors. And we're taking a square root of 24, so we're going to break 24 apart into its prime factorization. So if I were to look at 24 and try to factor it, I would make a factor tree and I would say, okay, well 24 is 2 times 12. 2 does not factor down any further, but 12 I can factor into 2 times 6. 2 again does not factor any further, but the 6 I can factor again. I can make that into 2 times 3. And then I have my prime factorization where all of these are prime numbers, and the prime factorization for 24 we could write as 2 times 2 times 2 times 3. So that means we have 3 2's and a 3. So if I rewrote 24 as 2 times 2 times 2 times 3, then I can look for anything that I have a repeat of. And if I have 2 2's, that means that's really a 4. I can take the square root of a 4. Anything that you have a repeat of underneath of the radical, you can pull that out as a single one, because squared means you have, so for example, 2 squared means you have 2 times 2. 3 squared means you have 3 times 3. So if you're taking the square root of something that's squared, you just get whatever you were squaring, the base. So here I have a 2 squared, and I'm taking the square root of 2 squared, so that I can pull out front as a 2. Then once we pull those out front as just a single 2, because I've taken the square root of 2 squared, then I look and I say, do I have any other numbers that are repeated? And I have separately, I have a 2 and I have a 3. Those do not repeat, So I cannot take the square root of them. I can't take a square root of 2. I can't take a square root of a 3. And even if I multiplied them together, I would get a 6, and I cannot take the square root of a 6. And so all I'm going to do is I'm going to multiply that back together, and I'm going to make it a 6. And so what I've done is I've taken my square root of 24, and I've made it into 2 times the square root of 6. Now you may be wondering, why did we do that? Well, first of all, we did that because mathematicians consider a radical to be simplified by separating out anything that you can actually take the square root of. And furthermore, if we look back at what we had as our solution, -6 plus or minus the square root of 24 all over 2, well, now instead of a square root of 24, we're going to write this as -6 plus or minus 2 times the square root of 6 all over 2. And then again, when we're looking at this answer, and you have to say, well, what can I cancel from top to bottom? Well, in order to be able to cancel in a fraction, you have to have multiplication. So to get the multiplication, I'm going to factor out whatever I have in common between these two terms. Remember, this is a square root of 6. This is a number. This is not a 6. It's whatever the square root of 6 is, which is somewhere in between. If you take, for example, the square root of 4 is 2, the square root of 9 is 3, that means the square root of 6 is going to be somewhere between 2 and 3. So this is a number that's something between 2 and 3. So you can't factor this 6 out of these because this is not really a 6, it's a square root of 6. But I do have a multiplier on the square root of 6, and that's a 2. And here, a 2 can factor out of this -6. So I get 2, and -6 divided by 2, I'm left with a -3. Then I still have my plus or minus, and my 2 I can factor out, and I'm just left with a square root of 6. And then on the bottom I have a 2, and I can cancel this 2 with this 2, and I'm just left with -3 plus or minus the square root of 6. And if I wanted to write that as two separate answers, I would write -3 plus the square root of 6 and -3 minus the square root of 6. And those would be my final answers for this quadratic equation that I had up here.